Okay, physics professor is pushed up a ramp inclined upward at the angle of 35 degrees. So this is the ramp. Here is the professor. And this is 35 degrees. As he sits in his desk chairs that slides on frictionless rollers. The combined mass of the professor and chair is 84 kilograms. He is pushed a distance of 2.3 meters. So from here to here is 2.3 meters. Along the incline by a group of students who together exert a constant horizontal force of 596 newtons. So that is that horizontal force. The professor's speed at the bottom of the ramp is 2.25 meters per second. Use the work energy theorem to find speed at the top of the ramp. So what did I do 5 years ago? So here is the initial speed. Question is, what is the final speed? So work will equate to difference in kinetic energy. Work of what? Work of all forces here. So we have work of the force of the students that will push upwards, and we have actually that normal projection, parallel projection to the plane of that force, and on the other hand we have same projection of the weight. So these two forces will be in collision. Work of that forces on this distance will be equal to the difference in kinetic energy here and here. There is a different approach to this, and that we'll try to explain later, but this is valid also. So work from here to here of this resultant force will be equal to the difference in kinetic energy, as you can see here. And okay, this is the force, overall force, this is the distance. So first of all we have that, as I said, students pushing in horizontal direction and parallel to the plane, or in direction, component of the force in direction of motion is 596 times cosine of 30. Why is that 35? Why is that? Because cosine of this angle is when you divide this thing with this thing. Okay, that is the first force. The second force is also projection on the direction of motion of the weight, and that is, as you can see, directed in opposite direction of the motion. Therefore there is a minus here, and that is mg sine of 35. Why is that sine? Because sine of this is when you divide this distance with this distance. So this is overall force, and times distance, that is the work exerted on the object. This is v1 is the initial speed, and that is initial mass. Mass is always the same here, doesn't matter. So this would be initial kinetic energy, and this will be here final kinetic energy. So difference in kinetic energy is equal to the work exerted on the system. So from here it's easy to calculate yourself that V2, or for complete written answer please follow the link in the description. If you want more of this, please subscribe and tell your friends. And that is the end. Now this is the first approach to this solution. Another very similar, what you could do is, now you have here, you could say you have initial kinetic energy here, and you have work of the external force, that would be this. That will be equal to the kinetic energy here plus potential energy here, and you will get the same result. So it doesn't matter if you use potential energy at the end, or if you calculate the work of the force that opposes the motion, you will get the same result. So just so that you do not confuse yourself. So that's it. Thank you. Bye.